Okay, this is the particle system I've been using here. Uh, I haven't made anything, so just to get started. Okay, I'm going to show the source code and see if I can make any improvement. Okay, that's it for now. Just very basic stuff, attraction, repulsion. Right now it's way too spread out. I'm gonna have to improve on that. Doesn't really look that great with all the dots just floating about. Okay, we're gonna start to improve on everything. That's good enough for now. Okay, this is the code for the particle system. Again, we're using Direct3D device. We need math for some mathematics like absolute and random. Okay, first we have the number of sprites, 10,000. Normally this is not optimized enough to have 10,000, but I'm using a trick where I only do the calculations once every 4th frame, so it speeds things up, but it makes things look a little bit uglier, but it works out enough. That's the number of vertices. Again, I'm not. You might want to have, instead of points, might have lines, so the number of vertices might be different than the number of sprites. So that's the sprite FVF, the sprite vertex XYZ. This is for two-dimensional. RHW is for two-dimensional coordinates, and the color of the vertex. I haven't implemented color yet. That's something I have to work on, but I haven't quite figured out how to do that yet. We're just getting started. Okay, so that's sprite location, and that's the vector that you move it by. Very useful to have both of them. You can just move the sprite randomly. Okay, vertex color again. That doesn't mean anything. That's this is the structure for all the sprites. World sprite structure, sprite count, that's all sprites, and the Direct3D vertex buffer. Okay, these variables, this constant here, that's the maximum speed that the sprite can go. I haven't quite optimized how to check that, but right now it works. That's for the bounce coefficient. When something bounces off the wall, it loses some energy. Like here it's 0.07, that means 70%, that it keeps only 70% of the energy, and that means 30% is gone every time it bounces off the wall. That doesn't do anything right now, but just something to remember. The screen width 1024. By the way, the screen width is very different from the size of the window. I'm scaling the window back and forth, and the size of the window changes, and the size of the drawing surface changes. And by having a screen width, I can have a constant size for a video buffer. Okay, MX, that's the mouse X. Right. At first I said to the center of the screen. That's not really important, but that's something I do. That's the force of gravity here. When calculating gravity, I don't calculate the gravity. I don't do the math very well, so I haven't quite figured out how to do the math. Okay, for random, I use my own random function that uses rand. I don't seed random because I'm not doing cryptography, so it doesn't matter if it's the true random number. I just need something to spread out, so we don't really bother with anything complicated. I tried doing my own random number generator, but it didn't work. So later I'm gonna do that. Okay, initialize the sprites. We set everything to random, the screen width, the screen height, so that the sprites are distributed all over the screen at the beginning. Okay, everything else is set to 0. We have XYZ for everything, even though we're doing only two-dimensional. Okay, we have the color set to white. Again, I'm gonna set it for different colors later, but for now it's fine. Okay, now the clipping. That's pretty simple here. If it's less than, if dx is less than 0, then we set it to 0, and then we reverse the direction. If it's less than 0, then we reverse the direction. Then that's the self-explained times the bounce coefficient. If it bounces off the wall, if it's beyond the region, then we just reverse the direction and it bounces, bounce. That's the same thing for all four. X, Y, X, Y. For 0 and screen height, more than screen height. Okay, limit speed. This one, it's useful enough. You don't want everything going too fast. But I do gravitate later, and that's completely wrong. But just the length of the vector that the sprite is going, the direction that the length of the vector that sprite is going. If it's more than maximum speed, then you calculate the maximum speed. The current vector divided by the length, and then times the maximum speed, so that everything stays in the same direction. It's pretty simple math, so I don't have to explain that one. Okay, here's why I'm stumbling. Okay, I have the vector xy between the target the mouse X in the current location of the sprite. Dot mouse Y that's the vector from the sprite to its target. The distance to the target, we make sure it's not 0. Then we divide the force of gravity. Here, the equation is supposed to be the force of gravity times the mass of 1 times the mass of 2 divided by the square of the distance. But I just assume that everything's 1. The mass of the gravity and the mass of everything's 1, so I don't really bother doing the full calculation. So it's just the force of gravity. If I was doing more complicated simulation, then I would need that, but I just use the force. That's good enough for now. But this is why I make a mistake here. I just set it to calculate the total force of gravity in that direction. So which is why I don't need I should probably put the limit code right here, the speed limit code right here, but I'm going to do that later. But for now, I don't really bother. It does create something kind of ugly, but it works well enough. So if there was multiple sources of gravity, this would be completely wrong. Well, it would work. It would work. I tested it. It works well enough, but it would be kind of wrong. So it doesn't really matter. I just set it that way. For now, it's good enough. Okay, now we initialize the world, set up the sprites, the sprites, and create a vertex buffer. Now we run the world. For the render thing, I should probably turn off the Z buffer. I have it turned down, but I don't use it at all. So, well, for here, I probably should turn it off. But I leave it on right now, so it doesn't matter. Okay, we clear the screen, clear the Z buffer set everything black, and begin the scene. Lock the vertex buffer. Okay, this is for calculating once every 4 sprite, every 4. C equals starts at 0, and then if C is more than 4, then C equals 0. Then we just rotate from 1, 2, 3, 4, 5. We count every 4th frame. That's for later. For each sprite, if C equals 0, then we calculate the gravity for the gravity so that it heads toward the mouse cursor. If we have gravity, then gravity can be positive or negative. Gravity force can be positive or negative. And we set the limit. This should be one function. It should speed things up to have one function. Like I said, I do this once every 4th frame. So if C equals 0, then we do the calculation. If C doesn't equal 0, then we don't do anything. If C equals 1, this is a lot of complicated stuff. I just pick a sprite at random and then calculate the distance between them. This is just to keep them from clumping up. The odds of 2 sprites being of random selected 2 sprites that are close together is very low, unless there's a bunch of them clumped up. This function doesn't do absolutely nothing. But if they happen to be clumped up, then this should cause them to move away from each other a bit. It doesn't do much, but it's if I don't put this in, I really notice a difference. It keeps them from clumping up together. Sometimes it works a little too well. Maybe 5 minus 10 is a little too high. Maybe I should select something a value a little smaller. 5 minus 110 times 0.1 or something, 1.0, just to make sure. Well, it's a little too high, and it should spread because it seems to spread out a little too much. But for now, it doesn't matter. Okay, we do the clipping. Make sure everything doesn't go off the screen. Then move the sprite, and then we move everything into the vertex buffer. I was thinking of just getting rid of TX and just putting everything into vertexes, but if you're doing lines or triangles or something more complicated, then each sprite is 1 point, each one vertex, and this could be a problem. So I leave it like that, and we set the vertex color. Okay, unlock set trim source. Not really sure. Actually, I don't need to put this right inside the sprite for each frame, but in case I'm doing more than just sprite, maybe I have a cube in the middle with different objects. I'll leave that here for now. It's not really necessary, but I'll just leave it here. I would have to remove this to a different function, but later. Just that it works. As long as it works, it doesn't matter. Okay, win main. First, we create the window. We set window pro. Like I said in a different video, that I had to create a simple window and then set the settings for later. That becomes a problem with some functions, but right now it works. Okay, we set the Direct3D device to window, screen height, screen width, and I hit world. Initialize the sprites. While get event, we run the world, which is run the sprites. When we're done, we close the device. Okay, here's where it becomes a problem. If the mouse moves and we get client ICT, and this is when setting the window proc after I create the window becomes a problem, because your client ICT should be in WM size. When you change the window size, it should change a variable which it gives you the window size, so that you don't have to do this every time the mouse moves. But because I set this, when you create a window, the set size, the WM size message comes after you create the window and before the create window returns. It sends the message and then this returns. So the WM size message would come before I reach this point. When I'm in this function, I would get WM size message, but it will be over before I reach this point. So WM so sprite proc would never get the WM size message. That's a bit of a problem, but unless you manually change the size of the window after you're done, or call a function that sets the window size. That's just too much stuff, so I just call it every frame, every time the mouse moves. That's a bit of a problem, but it's not bad. Okay, for mx equals the mouse x load and pound. That's the client. That's the position of the mouse within the client area, times the screen width divided by the client area. This right here would set, because the size of the, because this, imagine if this is the, if this does the whole window is, well basically the size of the window changes, but the size of the buffer does not. You can set, every time you resize the window, the whole window shows the whole buffer, even though the buffer could be 700 pixels wide, but the window client area is just only 200 pixels wide. It still has to match. So we do the calculations here: screen width divided by the total width of the buffer times the width of the client area, which could be very different from each other. So that way, when you click on the mouse, everything appears in the correct point in the client area. That's not too complicated. Okay, dump W button up. When you lift the mouse button, gravity gets reset to 0. So that way we end everything. Okay, L button down sets the gravity force to 9,000. You can try different values, just see what works. I haven't really calculated, but 9,000 seems to. If you set the value too low, everything spreads out. If you set it too high, everything gets clumped up. So I guess 9,000 is the value that I got. Okay, but let me close this file window. That's, if not, def window proc. That's pretty simple. Okay, that's it. Okay, this is the result. When you click on it, it sends gravity waves all over and starts sucking up everything. And pretty simple. Like I said before, I need to start adding colors, because I should set the color to how fast it's going, relative to how fast it should be at the maximum speed. That might give me something here. Okay, attraction, repulsion, everything gets sucked in. Because the gravity is so low, not everything gets sucked in. That's why you should set the gravity a lot higher, because some particles start to adopt a stable orbit and things don't get sucked in as they should be. And that's why everything gets so spread out. Sometimes you do too much, but it's the first attempt, so it works well enough. Everything moves well enough and doesn't get clumped up. You can try different effects like a water and it falls down, or you can try it. Well, I'm gonna improve it later, so for now it works.